If you have watched my last 2 or 3 episodes about Proxmox and faster internet with multipath and so on, then you have probably been waiting for this video. If not, don't worry. Here is what we do today. We build a network, but not just any network. In essence, we build a very simplified version of the internet inside a virtual environment. It's got a lot of features. The main feature though is here in the middle. We will use a web interface in order to tweak the different connections here on these shapers so that they can behave like mobile phone internet connections, for example. But without spending hundreds of dollars for hardware or exhausting your mobile phone internet plan on the first try. All virtual with free software. Stay tuned. Quick reminder, if you're in a hurry or you want to skip parts of the video, then use the chapters here on the timeline or in the description. Here's the breakdown of this episode. Thank you. I can hear you ask, Mark, why on earth would I want to build a virtual network? Well, first, thanks for asking. In fact, there are a handful of use cases for this. Maybe you don't have a network that you can play around with, but you want one. Here is a cheap and direct way to do so. Or maybe you want to rent a VPS, vServer, virtual server, or whatever you want to call it, or you already have one, but you want to test stuff in the lab before you put it to life in the real world. Or maybe you are looking for a way to simulate bad network connections, high latency, low bandwidth, etc., and see how things turn out. You can do all of this inside a virtual world, on the cheap, without purchasing a lot of hardware. Cool. Now we know why we want to do this. Next, let's see how we do it. I will show you how to build this inside Proxmox, but you could do the very same inside probably any virtualization solution, be it ESXi, VMware Workstation, Fusion on a Mac, Oracle VirtualBox, Zen or anything else. We just have to choose one, and I happen to have Proxmox here. We will build this environment from left to right. This way we will have internet access at every step throughout the deployment. We start with a perimeter router here that links our virtual and physical environment. That is, in fact, a virtual machine running OpenWrt. We will then build the 3 shapers here. I built them in LXCE containers, but you can do the same in virtual machines. I used containers, however, because they use much less resources. In a nutshell, you can probably run 5 or 10 containers with the resources you need for one single VM. Once we have that, we will then add all the other stuff like a client here or a machine with OpenMPTCPRouter and a virtual VPS server here. Awesome, now we know exactly what we want to do. Before we can build the nodes in a network, we need to set up the networks. Setting up a network in Proxmox is done in a couple of clicks really. You select your PVE machine here on the left, then click on Network. Here you can see all the existing networks. You should at least have one, which is your physical network. In my case, I have 2 of them. One is VMBR0 and one is VMBR1. They are just in different networks. Now, in order to create more virtual networks, you click on Create, then Linux Bridge up here at the top left. Give it a name and a net mask, and that's pretty much it. We don't need more. Here you can see the networks that have been created. I created networks in the 10.7, 10.8 and 10.9.x range, and one in the 192.168.56x range. But you can create them in any private network range. The IP addresses here do not need to be in the same network that your virtual environment will use. Basically, the address doesn't matter. If you do, however, choose the same IP network, then you can access that network from the outside, okay? Clicking on Apply Configuration up here makes the changes permanent. What I suggest you do is that you print out the blueprint here or make a drawing of the environment and just write down the names of the bridges here and where you want to put them. That will make the creation of the machines and containers easier in the next steps. Cool! We have created the networks and now we can start defining the nodes. Let's start with a perimeter router. We will use OpenWrt for this. if you have watched my video on how to build a virtual home network inside VirtualBox, then you probably remember these steps and can skip this chapter. For everyone else, here is how to install OpenWrt in a virtual environment. In Proxmox, we create a VM by clicking on this blue Create VM button here. Now, you need to give it a name and a unique number to identify it. The name can be changed later, the number cannot. Keep in mind that this name needs to be a valid DNS name, so no spaces and special characters. Next, Proxmox wants to know if we have an installation CD. We don't. We will use a ready-made image which we grab from the web later, so we select Do not use any media here. We don't care about graphics. But the next step is a bit overhead. We need to define a virtual hard disk. But as I said, we will get that later from the OpenWrt website. So in fact, we will scrap that disk and replace it with the one that we get from the OpenWrt website. Let's just make it small. On the next two screens, we define CPU and memory. We don't need much here. 1 core and 512 megabytes of RAM are plenty. As a network device, please use one of the bridges that we defined in the first step. That will actually be the router's LAN interface. We will add the physical interface, which is the router's WAN interface, in the next step. I untick firewall because I'm not using the Proxmox firewall here. As a hardware, I use the para-virtualized network interface. That's much faster than emulating real hardware, and OpenWrt deals very well with it. Quick summary. Let's confirm, but not start it yet. We will still need to add some more stuff. Once the machine is created, we click on it in the left column here, then select the hardware section and click on Add at the upper left here. Let's now add the outbound network. In my case, that's VMBR0. Again, I use virt.io and untick the firewall. We could also already detach and delete the hard disk, but let's do that in the next step. Let's browse to the OpenWrt website. I'm using a release snapshot of version 21.02, but you may use the recent stable version. Just keep in mind that there is a snapshot without the web interface, and then there is the releases which contain the web interface, Lucy. The one I want to use is under Targets, x86 Generic. Make sure you use the ext4 combined image, so the larger one. That's the second one here in the list. Copy the link location to the clipboard or download the image to your Proxmox machine. I connect it to the Proxmox with SSH here and just download the image with wget. Paste the URL. Next, unzip the image, for example, with gunzip, and then you may convert it using the qm-img convert command, or directly import it into the VM using the qm import disk command. The commands are in the description of the video, don't worry. Once the qm import disk is finished, it then shows the name of the new unused disk here at the bottom. Back to the Proxmox interface. Here we can see the newly imported disk. Now we first need to detach and then remove the old disk. In the next step, we select the new disk, then we click on Edit, select the IDE controller and confirm by clicking on Add. That attaches the disk to the VM. Before we can boot the VM from that disk, we need to go to Options here, then edit the boot order and actually tell the VM to boot from that hard disk. Perfect. Once we click on Start in the upper right corner, we can then check the console of that VM and it should show group coming up. Inside the console we can quickly check if the network adapters have been attached in the right order by typing IP-ADDR. And what we should see is that the outbound WAN interface, which is Ethernet 1 in OpenWrt, has an IP address from your physical LAN, and that BR-LAN, which is the interface pointing towards the inside of our virtual network, has been given the 192.168.1.1 address. If you want to change the router's address, then you can do this now by typing UCI show network.lan. Here you can see the settings of the LAN interface, and you may change these by using the UCI set command. Like I do here, UCI set network.lan.IP-ADDR and then the IP address you want it to have. UCI commit and reboot. Checking with IP-ADDR right after the reboot should show the right IP address. If everything went well, we should also be able to ping a host in the internet. If that doesn't work, then please double check on all previous steps before you move on. Perfect! We have successfully created our first VM inside the network, which is in fact our perimeter router to the physical world. This VM connects our virtual network to our physical LAN and ultimately to the internet. We can now move on to the right and create the shaper machines. Right after this, call to action. I need you to get involved, please. I have a couple of questions that only you can answer. First question, of course, please let me know in the comments if this episode is useful for you, if you have a use case for it, and if yes, which one? Second question, should we build this in Docker? I mean, would you be interested in building a network in Docker? And the third and last question, I had a look at the command line interfaces of Proxmox. And in fact, we could automate the deployment of this environment. That means you would launch a script and that would build this whole network for you. Would this be something you would be interested in? Please do leave me a comment. Many thanks. Over to the Shaper installation. The Shaper machines will be LXCE containers, so in Proxmox we click on Create CT. Again, we give the container a unique ID, a DNS name, and also we need to specify a root password here. Next, we select a template to use. I select Debian 10. Next, tell Proxmox where to store the disks of the container. I put it on local LVM, which is in fact on my SSD drive. That will be much faster. Also, the size of the disk is quite small. 8 GB is plenty, 1 core and 512 MB is a lot for what we want the machine to do. Now in the next step, we define the network interface that points to the outside. In my case, that's VMBR6. I set the protocol to dhcp because my perimeter router will provide IP addresses on this interface. Confirm, and then Proxmox will create the container. Just need to add a second interface under the network section here, which I call Ethernet 1, and that's one of the 3 bridges to the right here on my diagram. I choose VMBR7 and give it a static IP address according to my blueprint. In my case, 10.8.0.1.1. I'm adding a third interface here, but that's just for the sake of making the video, because this way, rather than accessing the Shaper via the PVE console, which is a bit hard to read on the video screen because of the white on black, I can rather SSH into the container and use different color and font settings. Just for the sake of not ruining my viewers' eyes. You don't have to do that. Perfect! The first Shaper machine is up and running. As I have added that second interface, I can now SSH into it and do a couple more things here. In a nutshell, the next steps are to tell the Shaper that it should act as a router. We do this by first enabling IP forwarding. Then we will be NATing or masquerading the outbound interface towards the router, and also I want it to act as a DHCP server for all the machines that are behind it. Last but not least, we will create an SSH key pair so that we can remote execute commands on the Shaper. That will be important once we tweak the quality of the network lines. Let's go. Turning a Linux machine into a router is just one flag in the operating system, really. We can do this by setting the net.ipv4.ip_forward flag to 1 with sysctl. The box will now forward traffic from one network to another, just like a router does. We can make that change permanent by adding or uncommenting the setting here in the /etc/sysctl.conf file. Here's the line. Just need to remove the trailing hash. Alternatively, we can put these commands into the /etc/rc.local file, which is executed each time after boot. I have also put the iptables command in here, which actually masquerades or nats outgoing traffic so that the packets, which we send to the internet, can find their way back to us. All files are on the GitHub, plus the commands to use are of course in the description of the video. Just quickly checking if I have internet connection. Yep, that's good. So we can now install some additional software. Let's first run apt update in order to get an updated list of available packages. We want to install 3 packages. The first one is bmon, which is just a tool to show network speeds. We will use this to monitor if and how the network is used. Next package is the DHCP server. I use ISC DHCP server for this. Last but not least, I also install speedometer, which is another tool to monitor network bandwidth. Cool. Now let's set the DHCP options. I want this Shaper to be a DHCP server. The options for this are configured in /etc/dhcp/dhcpd.conf. In this file, you can specify the networking options which the shaper should provide to the machines behind it, such as the name server. In my case, that's my physical main router, the 139.139 address here. Then you define subnets and options per subnet. The one that is important here is the 10.8 subnet. It tells the client to use 10.8.0.1 as a default gateway. It tells them that the domain they are in is called testnet.lan, that they should use my main router as a DNS server, and I also specify an IP range which they can get automatically. In my case, the .100 to .120 range. Last but not least, I need to tweak the dhcp server in the sense that it needs to know which Ethernet interface to serve and which protocol family. I will only be using IPv4, so I just need to set the interfaces v4 option serially and set it to Ethernet 1 at least. Now I restart the dhcp server by issuing the systemctl restart isc dhcp server command and double check if there are any entries in the syslog by grepping for the word dhcp in the syslog to see if everything went well. As you can see, the server stopped and restarted properly. All good. We are ready to provide IP addresses over DHCP just like a real router does. So now, just one last thing that we need to do before we're done. In order to tune the network interfaces, we will need to execute commands on this shaper machine from a distance. For this we will use SSH. But I don't want to type a password for this or to hardcode a password somewhere. Therefore, I created a key pair using the SSH keygen command. I leave all parameters at the default value just by hitting enter each time. That means that I don't add a passphrase neither. Do not do that for servers which you access in the internet. It's just something we may do here in our safe lab environment. The keys have been added into .ssh/id_rsa and I now just need to tell the SSH daemon to use them. That's done in the /etc/ssh/sshd_config file. Just need to add the path to the keys here. That's it. Awesome! The first shaper machine is ready for use. It acts as a router, it distributes IP addresses, and it can be accessed using SSH public key authentication. You may now either do those steps 2 more times in order to create the other 2 shapers, or you might just clone the container by right-clicking on it and selecting Clone in the context menu in Proxmox. Once you cloned the machine, you would of course need to change the second network adapter to serve the right bridge and adapt the DHCP settings to serve on that bridge. If you want, you can also regenerate SSH keys in order to have different keys for each machine, or just use the created ones. Perfect! Our network is growing and we can now add the right-hand client machine which connects to the bridges and the VPS. Same procedure here. We generate a virtual machine, just this time I need to give it a bit more juice. I choose 32 GB as a disk size and give the machine 2 GB of RAM. As a software, I install Debian 10 again. I won't show how to install Debian 10. That's really just questions and answers. Just make sure that you don't install unnecessary software packages. The most important one is to have an SSH server selected. The VPS needs to get the bridge here as a network interface, and if you want to install a client like we did in the MPTCP video, then you need to give it the 3 shaper bridges as a network interfaces. That's pretty much it. If you want to install OpenMPTCPRouter, then please refer to the OpenMPTCPRouter video. In a nutshell, proceed like for the OpenWrt router. Just this time, use the corresponding combined ext4 image from the OpenMPTCPRouter.com website. Assign the rightmost bridge as a first interface. That will be the router's LAN, and the 3 shaper bridges as a second, third and fourth interface. That's pretty much it. In the OMR settings, you just need to switch the protocol of the WAN interfaces to DHCP. On the VPS, you may run the OpenMPTCPRouter VPS script if you want to use this for OpenMPTCPRouter. Again, please watch the OpenMPTCPRouter video on how to do this or check the description of the video. Perfect! Depending on what you want to do with the network, you should now have one of the following layouts. Either you just have a client machine here, or you have OpenMPTCPRouter, or maybe you have both. In case you only have OpenMPTCPRouter installed, we would need to add an additional client here to the very right of the schema in order to run the web frontend, which will allow us to tweak the network speeds of the shapers. I will again use a container for this, but you could also install a Windows machine or alternatively add a physical network interface and attach an existing physical machine here. But I will show how to do this in a separate video. For this video, I will use a Linux container and install a graphical desktop environment into it, which we will access using the X2GO client. So again, we create a container from the Debian 10 template like we did before. 8 GB of disk should do. 1 CPU is fine, just I will give it a bit more RAM and swap. 2 GB of RAM and 1 GB of swap should be more than enough. Network-wise, I attach the machine to the outmost right bridge on our diagram, which in my case is VMBR 10. And also, in order to be able to access it from the outside, I attach a second network interface. In my case, I use my IoT network for this, but you could also use the LAN. Just need to make sure that you give it a fixed IP address in order to avoid that the machine gets a default gateway from that interface and goes to the internet through it. We want the container to go through the shaper machines. Alternatively, you could also map a VLAN through to your workstation. I did this by adding a USB Ethernet interface to my workstation and mapping it to a cable on a switch next to my desk. But don't worry, I will make a separate video on that as well. Cool. As soon as the container boots, I will have to install 3 software packages on it. But first, I need to create a non-root user. It's really important that if you launch graphical user environments in Linux, that generally you do this as a non-root user. In my case, I create a user called Mark by typing @user_mark. Give him password and a name. The usermod-a-g sudo mark command adds me into the sudo group in case I want to run stuff as root using sudo later. Next, let's install the graphical environment. I want to install X2GO Server as a remote viewer, Mate as a desktop, and Firefox-ESR as a web browser. That's all. I also install sudo by typing apt install sudo on top. Cool! Now we have a client here at the end of the daisy chain, and we want of course to connect to it using the X2GO client. Let's actually do that from a Windows PC. You can get the installer from x2go.org. Click on the MSWin link here, download and install. Work through the installer and launch X2GO. The first time you launch X2GO and create a new connection, it will probably trigger Defender. Just make sure that you allow access if you want to use audio, for example. In the Session Preferences window here, I need to type in all details of the connection, such as the name or IP of the VM, the SSH port, and the username which it will use for a connection. I set the session type to Mate, as this is the desktop environment which I have installed on the server. There are a couple of other parameters which you may set depending on your environment, such as the screen resolution, access to the clipboard, the speed of the line, if you want to have audio, etc. Once you finish this, you can now access the connection by clicking on the newly created tile on the right part of the screen here. Most probably, Defender will come up again and request access. Let's grant it. The first time you connect, X2GO will also ask you if this is the right machine to connect to. Just say yes. Awesome! I'm now connected to the client in the virtual environment and can open a browser and point it to my OpenMPTCP router, for example. In order to do this, I browse to 192.168.100.1 and I can start administering my OMR router. Our network is now complete. We can start using it. We have remote access into the environment and traffic is routed through the three shaper machines. The very last, but by no means least thing that we want to do now is that we want to install the web frontend for the shaper machines. That allows us to tweak the network parameters. Remember, we wanted to turn those excellent network lines here into bad lines and hence simulate 4G or LTE characteristics such as low bandwidth or bad ping time. Let's go. The method that we will use in order to tweak the network lines is that we use the quality of service interfaces that are built into Linux. In essence, we modify the queuing discipline of the network interfaces of the shapers in order to add latency, reduce or increase bandwidth, or add random errors to the transmission. Don't worry too much about the details. I will make a spin-off episode on the details like quality of service, queuing disciplines, schedulers and the like. Just so much that the command which we will use to achieve this is called tc in Linux. The tc command allows us to add, modify or remove a scheduler to a given network interface. In our case, we want to use the netem filter that allows us to do exactly what we want. We can modify bandwidth, latency and error rate. One thing is a bit inconvenient though. In order to modify the lines on the three shapers, we would have to SSH into each of them and type cryptic tc commands on the command line. Therefore, I have written a small and simple web interface to do this using nodejs. What it does is that it takes the parameters from a graphical page, connects to the machine using SSH and executes the tc command with the right values on that machine. You can obtain this from my GitHub repository. The link is in the description of this video. You may either browse to the repositories tab here, then to MPTCP tools, where you can find the script in the nodejs subdirectory. In a nutshell, this is a JavaScript file where you define the servers in lines 90 to 24, so you might need to adapt this to your environment. In order to get the code, go to the code button here and download the zip file or copy that link, which we will use with Git in order to install on our client machine. So let's connect to our Mate desktop client. Then we need a shell, which we can find under System Tools, Mate Terminal, and here we just quickly need to install Git. Let's become root with sudo, and then as root run apt install git. Now you can clone the repo by typing git clone and the URL which you have copied from my GitHub site. Now cd into the MPTCP tools directory and from there into the nodejs directory. In order to run the script, you need nodejs. Again, as root, we install nodejs by doing apt install nodejs. Node.js is a nice and quick way of running web front ends with JavaScript actually. I love it. Let's adapt the script quickly. We don't need to use nano or vi as we have a full desktop here, so we can run the file manager, which is called Kaha in Mate, by browsing to Applications, System Tools, Kaha. In Kaha, we go to the same subdirectory and open the qdisks.js file with Pluma, the built-in editor for text files. Just make sure that you adapt the IP addresses in that file to reflect the IP addresses of the shaper bridges. You can double check those, for example, in the OMR interface if you have installed OMR. Once you have saved the file, run node qdisks.js in the terminal. That will start the web interface. You can now launch Firefox under Applications Internet and browse to localhost :8080, which will show the web interface. That shows a very simple form with one block for each shaper and one line for each interface on that shaper, where you can set the parameters for rate, that's the bandwidth, delay, that's the latency in microseconds, so 50 milliseconds would correspond to 50,000 in that field, and you can add a percentage of error rate. Below I added a big text box that will actually show the results of the command. But before we can launch a command remotely on the shaper machines, we need to copy the SSH keys over to this machine, which will then allow us to remote execute the tc command on the shaper machines. You remember? So let me open another terminal and SSH into one of the shaper machines. In my case, I go to 10.7.0.1. The keys which we had defined are in the .sh subdirectory. By default, the key is called id_rsa. Now you can either show the content of that key by typing cat id_rsa and then paste it into a new key file on your client machine using vi or Pluma. Just make sure that you give it the very exact name like you specified in the script. In my case, that's id_shaper1. In order to make it usable, the key needs to be restricted in access rights. In order to do this, type chmod 600 id_shaper1. Perfect. Back to the interface. Let me type in some parameters and then click on apply. That didn't work. Why? Actually, my Shaper1 is on the 10.8.0.1 interface, so I got the wrong key. But I need to get the other ones anyhow. So same procedure to 10.8.0.1, cut the key, copy it, exit, rename it ID Shaper1 to ID Shaper2, then create the Shaper1 key, paste the key, write and exit, try again. Forgot to chmod, try again. And it works. I have just added 100 milliseconds on both interfaces, which should sum up to 200 milliseconds latency in total. Let me browse to my OMR and see if it took note of it. Absolutely. The 1-2 interface here jumped to 200 milliseconds, all working as expected. Now, getting the keys with SSH and copy-paste is not everybody's turf. So let me show you an alternate way of copying those keys over to the client machine. We may as well use FileZilla to copy the keys. So in a terminal, we install FileZilla by typing sudo apt install FileZilla. We can now launch FileZilla under Applications and then Internet. In order to connect to the Shaper, we just type the IP address in the host field, root as a username, the root password, and 22 as the port. FileZilla will then connect over SSH or rather SFTP. In the right window, we can now see the files on the Shaper machine and can easily copy the key file over by either dragging and dropping it to the local machine on the left or by just double-clicking on it. We can also directly rename it from here. A nice side effect of this method is that we don't have to chmod as the file keeps the permissions from the source machine. Right, we are all set and can now start and make the connections really bad. OMR should pick this up any second. Here we go. Guys, that's it for today. Join me on Sundays on Discord for video chat or screen sharing if you have questions. Contact me on Discord, Facebook, Messenger or Reddit if you have questions or remarks. If you liked the video, please do leave me a thumbs up. Much appreciated. Last but not least, if you want more, please do subscribe and also click that bell or notification icon. Guys, many thanks for watching, liking, commenting and subscribing. Stay safe. Stay healthy. Bye for now.